All right, today we're going to dive into something called event-driven architecture, or EDA for short. Now, this might sound a bit technical, but trust me, it's one of the most powerful ideas in modern software. It's kind of the secret sauce behind a ton of the apps you're probably using every single day.
So, let me ask you this. What do Netflix, Uber, and even Git, the version control system we all rely on, what do they all have in common? I know, it sounds like a random bunch, right? But believe it or not, they all share this core architectural philosophy that lets them handle just insane levels of scale and complexity. And yep, you guessed it, that philosophy is exactly what we're breaking down today.
But, to really get why this new way is so important, we've got to look back at the old way first. For like decades, the internet has pretty much been built on what's called the request-response model. Think of it as a world full of direct, one-to-one API calls.
The best way to picture this is to think of a direct phone call, right? Service A needs something from Service B, so it literally picks up the phone, dials B's number, asks its question, and then it just waits. It's stuck on the line waiting for an answer. This creates what we call tight coupling. Both services have to know each other's exact address, and they both have to be online at the exact same time for it to work.
Okay, but what happens if Service B's line is busy? Or worse, what if it just doesn't pick up the phone? In the software world, this is where things get messy. It creates a domino effect. If just one service fails, it can set off this chain reaction of failures across every single service that was waiting on it. The whole system becomes incredibly fragile, or brittle.
And this is exactly where event-driven architecture completely changes the game. It offers a totally different and way more resilient way for systems to talk to each other. We're moving away from those direct phone calls to, well, something else entirely.
So the core of EDA is this little thing called an event. Now, an event isn't a command, it's not a request for information, it's just a simple, factual statement that something important happened. Think of it like a headline. User clicked play, or order was placed. And here's a key detail. Events are immutable. They're like historical records. You can't change what happened in the past.
This whole architecture really just boils down to three simple parts. First, you've got the producer. This is a service that sees something happen and shouts it out as an event. That event then goes to an event broker, which is kind of like a central post office or a message board. And finally, you have the consumers. These are other services that have said, hey, I'm interested in those kinds of events, and they just listen for the broker to deliver them.
So let's go back to our analogy. If the old way was a direct phone call, EDA is much more like a radio broadcast. The producer is the radio station, just broadcasting information out into the world. The station has no idea who's listening, how many people are listening, or what they're going to do with that info. The consumers? They're just people with radios who can tune in to the broadcast whenever they want.
Okay, so now that we have the basic idea, let's do a real head-to-head comparison. We'll put these two models side by side and see how they stack up on some of the most critical factors when you're designing a system.
All right, first up, coupling. We've already talked about this, right? The request-response model, our phone call, creates these really tight dependencies. But with EDA, services are what we call loosely coupled. I mean, they're basically strangers. The producer has no clue who the consumers are, and the consumers don't know the producer. The only thing they both know about is the event itself. That's the common language they share.
And this decoupling, this is what unlocks some insane scalability. Think about it. In a tightly coupled system, if one service slows down, it becomes a bottleneck and drags everyone else down with it. With EDA, that problem just disappears. Scaling is totally independent. If you suddenly get a huge spike in events, you just spin up more consumers to handle the load. The producer doesn't have to change a thing. It doesn't even know it's happening. That is a huge advantage.
Which brings us to our next point, fault tolerance, or basically how resilient the system is. We already said the request-response system is brittle. If the receiver's phone is off, the call fails. End of story. But in an event-driven system, if a consumer service goes offline for a bit, it's really not a big deal. The event broker just holds on to that event, kind of like your post office holding your mail while you're on vacation. And when the consumer comes back online, boom, the message is delivered. The rest of the system just keeps chugging along, totally unaffected.
But as always, there's no free lunch, especially in software architecture. All this amazing flexibility and resilience, it comes with a pretty significant trade-off. And it's one you absolutely have to understand before you even think about using EDA.
And that trade-off is all about data consistency. See, with a phone call model, when you hang up, you know the conversation is over, the task is done, the data is immediately consistent. But with EDA, because everything is happening on its own schedule, asynchronously, there's a tiny delay. We're usually talking milliseconds here, but it's a delay between the event being sent out and all the consumers finishing their work. This is a really important concept called eventual consistency. It means the system will become consistent eventually, just not instantly.
Okay, I know this might all sound a little abstract, so let's make it super concrete. Let's take a look at how some of the biggest companies on the planet use EDA to run their operations at a mind-boggling scale.
Just look at this number. Netflix processes over 1 billion, with a B, over 1 billion events every single day. Think about that. Every time you hit play, pause that show, or give it a thumbs up, you are firing off an event into their system. Trying to manage that sheer volume of traffic with a traditional phone call model, it would be, well, pretty much impossible. And it's fascinating to see what they do with all those events. When you start watching a show, that one play event gets broadcast out. The recommendation engine grabs it to start thinking about what you might want to watch next. At the exact same time, the analytics team picks it up, the health monitoring systems see it, dozens of different services all react to that one single event, all working in parallel, none of them having to know about the others. It's incredibly efficient.
Uber is another perfect example of this one-to-many power in action. When you tap that button to request a ride, your phone sends out one single event, ride requested. That one event is immediately picked up by multiple different services. The matching service starts looking for a driver. The pricing service starts calculating your fare. And the ETA service figures out how long you'll have to wait. 3 totally separate jobs, all kicked off by one little event, all happening at the same time.
So, okay, with all these superpowers, you might be thinking, should I just use EDA for everything I build? And the answer is, probably not. It's an incredibly powerful tool, for sure, but like any specialized tool, you only want to use it for the right job. You really want to reach for EDA when you're dealing with things that need huge scale and elasticity, when you need services that can operate independently and be super resilient to failure, and when your workflows are naturally asynchronous. But you have to be ready for the other side of that coin. It definitely adds complexity. Debugging can be a real headache when you can't easily trace a request from start to finish. And you have to be okay with that idea of eventual consistency we talked about.
So the bottom line is this: event-driven architecture is not a silver bullet. It's not going to solve every problem. It's a strategic choice. For a lot of simple, straightforward tasks that need an immediate, confirmed answer, that classic request-response model is still often the best way to go. But when you're building complex, large-scale systems that need to be incredibly scalable and resilient, well, then EDA is very often the key that unlocks that door.
And that leaves us with one last question for you to think about. When you look at the software you build, or even just the apps you use every day, try to picture how they communicate. Is it a series of direct one-to-one phone calls, or is it more like a public one-to-many radio broadcast? Just understanding that difference, well, that's the first huge step toward building better, more robust, and more scalable software for the future.